There are a lot of cases where a derivative would not exist at a particular point. First off, a function has to be continuous at a point for the derivative to exist. If you know a function is differentiable, then you know it's continuous. Differentiability implies continuity. It does not work the other way around. Just because you're continuous does not mean the derivative exists everywhere. And here's a couple of reasons that might not happen. First, any kind of sharp corner is going to hurt the derivative. Let's think about tangent lines on this graph. So consider right here at x equals 0. Well, over here, all of my tangent lines, all of them have a slope of -1 on this side. So if I wanted to do like a one-sided derivative, the limit as h approaches 0 from the left of f of x plus h minus f of x over h, the so-called left-sided derivative, that would just be -1 because all of these slopes are -1. But on this side over here, all of these guys have slope +1. So if I were to actually calculate the limit as h approaches 0 from the right of f of x plus h minus f of x over h, I would get +1. So one side says the derivative wants to be -1. The other side says it has to be +1. It can't be both. Limits only exist if both one-sided limits agree. So here the limit does not exist. F prime at 0 does not exist. You can't have a sharp corner. Similarly, you cannot have an infinite slope. So the slope of the tangent line, this is a perfectly good graph. It's continuous, but right there at x equals 0, the tangent line is vertical. If we're coming in here, look at these slopes. That's like maybe a slope of 1/2. Now a slope of 1, a slope of 2, 3, 4, 10, 1,000. Same as I'm coming from the other side. Here's a slope of, I don't know, maybe 5. If I keep going, the slopes are getting smaller. But right here at this point, the slopes are vertical. So the tangent line is vertical. So in a sense, I'm going to write this and then I'm going to erase it. It's kind of like f prime at 0 here is infinity. It's an infinite slope. But we don't say that. We never say we have an infinite slope. And like there are two ways to argue it. Sometimes you could say what's positive infinity, it's negative infinity. We just never say we have an infinite slope. Like we might kind of say that hand wavy like I am right now, but we wouldn't write it. So we would just say does not exist. Because the limit will not exist. Remember, this is the definition of the derivative. The limit as h approaches 0 from both sides. And that only exists if we get a finite number. And if we were to actually calculate that limit here, we would get infinity, which is not a finite number. Limit does not exist. So anytime you have a sharp corner, an infinite tangent line, or the function is not continuous. If you've got holes in your graph, you will not have a derivative. Another thing that can go wrong, these are weird, these don't come up often, but if your function just never settles down, like this function is continuous, we proved this in an earlier video, or at least we looked at it numerically. This function is continuous, but it keeps waving and waving and waving faster and faster. If we could zoom in right here at x equals 0, these waves get faster and faster and faster, and the tangent lines just never settle down. So here the limit of the derivative would not exist. So the derivative would not exist.